Hello and welcome to Class Time CSEC Math. I am Denise Bailey.
And I'm Shadeen Cassie.
Today we are exploring the final topic in our measurement series, maps and scale drawing. So let's get started. Now, I have been home, working from home, and I got a bit tired. I needed some exercise. So my son went and got a trail for us to go and, explore nature. And I saw, this is the one I picked. But when I started the journey, Shadeen, it took forever. And I was saying to him, but my son's name, I said, but this is too long. This is not what I saw on the map.
Right. So Denise, looking at the map, you did not examine your map carefully because there are some information that is very important before you start the trail. And I'm not just talking about the river that's running through
which was awesome, I must say.
Right. So
yes.
There are some information that you should have examined.
Yeah.
In particular, I'm talking about those little numbers, figures right there. That ratio that's
I did not look at the ratio. I honestly did not.
Good.
And so we look at this, and so
it gives us some information. So that would have prepared you for taking the journey.
Okay.
So for today, let's go into the lesson to see what this information means to us.
Okay. As we go on, we'll look at what are scales. A scale is the relationship between the distance on the map and the actual distance on the Earth's surface. And that is what I did not take into consideration.
Right. So
the scale of the map that I had for my little rest and relaxation.
Right. For this map, the scale was at the bottom right-hand corner.
Yes,
but
yes.
It could have been written just about
anywhere on the map.
Right.
That is good to note. Also, in our conversation, as we go on, I'll encourage you to look out for these vocabulary words. We'll be using them consistently, and so I ask only that as we go on, you make notes of what they mean, what they are, and how it is that they help you to better understand what it is we're doing.
Right.
And these words are, we had said scale and
actual size,
okay,
distance, area, and map.
And of course, map.
Yes.
Good. So once we talk about a scale, you spoke about where it was located on the map, and it had a special look, a special typeface. And I want us to look at the three ways in which the scale could be written. We have the direct statement scale, represented in the red cloud there. We also have the representative fraction scale and the linear scale. Of course, we would see either of these on a map or a drawing, and
yes,
this gives us additional information. But what does it really mean? What do any of this really mean?
No, what does the scale mean? The direct statement scale is the ratio uses words to describe what a distance on the map represents in real life.
So what is on the map, it has a measure, and I can match that measure to a distance that is actually laid out somewhere on the Earth's surface in real world.
Right.
Okay.
For example, 1 centimeter, 2. Those colon there, 2, 10 kilometers.
Okay.
And the 1 centimeter is the unit on the map.
Good, good.
And in real life, we could not have drawn 10 kilometers on a book page.
Not at all, not at all.
So the 10 kilometers is the actual distance in real life.
So for the direct scale, we see what is on the map
first
to what is the distance in real world.
Yes.
And words are used. You will see the unit notation, the units being shown there. Okay. And then we go to what we call the representative fraction scale. Now, this is a ratio that does this. The first term in the ratio speaks again to the unit on the map, what is on the map. But the second term speaks to the distance in real life that is the same unit as the first term. So if the first term was in centimeters, then of course the second term would also be in centimeters. And we need to know that this is so whenever we go to problem solve. Fair?
Yes.
And then we have Okay, so here we have that we have 1 to 25,000 means that 1 centimeter on the map corresponds to 25,000 centimeters on the ground. And that means that if we were to do some calculations, of course, that 2.5 centimeters would be equal, 2.5 centimeters on the map would be equal to 0.625 kilometers in the actual real world, on the Earth's surface. And we have this one. Now, persons who do a lot of geography, map reading, things of those nature, they often see this one represented also. And this is a linear scale. What is it?
The linear scale is a special ruler on the map which shows what a distance on the map represents in real life.
Yes.
So for persons like in geography where they do contour drawings and stuff, then this is what they use most of the time.
That's right, that's right. So let's see how it is we're going to be using this information. Now here we have this resort. It's called Slippers Resort, right? And here's a hint. The entrance to the buildings are marked with a cross on the map. So wherever you see the cross, the cross is on the map, that would speak to the entrance to the building. Good? And there are 2 questions that we need to have answered here. The first would be, what is the distance in real life between the pub and Hotel Sun in meters? And the second question is, how far is it in real life from Super Shop to the beach bistro in meters? Good. So let's look at it. First question.
What is the distance in real life between the pub and the Hotel Sun in meters? So here is the pub and the Hotel Sun is right there.
Okay.
So the total distance would be a line drawn right there.
Okay.
Now the scale is important. And what kind of scale are we using here?
That looks like the direct statement, because included in it is the units to tell what each term means.
So for every 1 centimeter on the map, it represents 10 meters in real life.
Good, I can work with that. I understand that.
So let's examine our map to see how many centimeters are we trying to convert to real life. So it's 1. This is our starting, so that's our 0 mark. Touch.
Yes, that's our 0 mark.
So it's 1, 2, 3, 4 centimeters.
Okay.
And if there are every 1 centimeter, it is 10 meters.
So if there are actually 4 centimeters, then we have the 40 centimeters.
Right.
40 meters.
40 meters.
Okay, yes. I can, simple enough. Now, if I had this information when I went for my trail, I would not have found myself in such agony. So let's go. The second question says, how far is it in real life from Super Shop? Where is Super Shop? We identify the entrance to Super Shop.
Is right here.
Good. To the beach bistro in meters. And of course, we're using again a table to help us to clarify the information. Tables are quite helpful, right? And we have the information there. But first, we need to be able to identify the locations, and that's it right there.
Right. So, and we need to emphasize too that some persons might start counting at the starting point, which is 0. So it must be 1.
Yes.
This is our 0.
Yes.
1, 2. So it is 2 centimeters that we want to convert to meters.
Okay. And the scale says for every 1 centimeter, we have 10 meters. So if we have 2 centimeters, again, using our table, we would have 20 meters. So the answer for that is the distance. How far in real life is the Super Shop from the beach bistro? 20 meters.
Yes.
Okay, that's information. Now let us try this one.
All right. So now try this one. So we are going to actually be using the information. We would have garnered some understanding how to go about doing this conversion.
Yes.
So a map has a scale of 1 centimeter to 5 kilometers.
Okay.
So we need to make note.
Okay.
The scale is 1 centimeter to 5 kilometers. On the map, the distance between 2 towns the two tones, A and B, measures 6 centimeters.
So we have that information. For every 1 centimeter, it would be 5 kilometers. So if I have 6 centimeters, how many kilometers would that be in real life? I hope you're seeing the pattern and you're understanding, getting an appreciation of how to problem solve.
Now, what is the actual distance between the two tones? So we want to find the real life distance.
Okay. So we identify the scale. We know what the distance is on the map.
Yes.
And now we need to understand or find out what is the distance in real life. Okay. So is a 1 to 5, 6 to... Okay.
So if you're thinking about ratio,
yes,
then that could work. Or if I'm just there, I say 1 centimeter would be 5 kilometers, 2 centimeters, 10,
and
15.
So, yes.
Right. So let's see.
We use it is multiplication or repeated addition, whichever one.
Right.
So the actual distance from point A to point B, as represented on the map, would be 30 kilometers.
30 kilometers.
Awesome. Not bad at all. I tell you, a little information. Information is good. So we see that the actual distance between the two towns would be 30 kilometers. Good. This one, on a map of an urban community, the scale of 1 centimeter to 2 kilometers is given. If the actual distance from point E to point F is 9 kilometers, then what would be the measurement on the map?
Remember, we need to read the question carefully.
Get our information out.
Get the information out.
Yes.
See what we want, what we have, and then we see what we are trying to find. So in this case, we are not finding the actual distance, but we are finding the distance on the map.
Okay.
Right.
Scaled down. Okay.
The scale is given 1 centimeter to 2 kilometers.
Okay.
Now, what kind of scale is this?
It's the same direct representation. Direct statement.
Yes. And the actual distance is also given. So in real life, the distance that we're working with is
9 kilometers.
Yes.
Okay.
And we want to find the measurement on the map. So if you were to draw this map, what would the measurement look like?
Okay. Yes. So of course, the distance on the map, based on the information that we have, we would see that it would be the 9 kilometers divided by 2 because of the information on the scale, which would give us 4.5 centimeters. So whenever I'm drawing this information on the map, I would use 4.5 centimeters to show the distance between point E on the map and point F on the map. Okay.
Denise, in short, we could, just to summarize the information there, or our solution, it could have been 4.5 centimeters to 9 kilometers.
Yes, that is true. That is true.
It could have been that, right?
Yes.
Just to summarize our solution, it will emphasize that we are using the same scale if we were to simplify.
Yes.
And the distance, the information given would not have changed.
Good. That is true. That is true. So let us go into some practice questions. We've explored the expectations, how it is we can use this information to do our different calculations. Let us look at a practice question. Now here we have a blueprint.
Architect.
Thank you.
Architecture, right?
That's exactly.
Want to make a building
Who
of
would
some
need
sort.
to read this information?
A contractor.
And builders, right?
And builders,
so
yes.
contractors and builders, you need to pay attention. When it comes to scale drawing and map reading, all of this, you need to understand.
Because one slight mistake, if you're off by just a simple mistake,
1
it
point,
can cost
1
you
centimeter.
a lot of money. And remember, we talked about the salary and the wages before. So we want to keep our money right where it belongs. We want to stick to the budget.
That's right.
So we have to be, it is important to be able to do this kind of conversion, interpret the blueprint.
Thank you. So on the blueprint of a house, it shows 10 centimeters representing 2 meters. So on the blueprint, it's 10 centimeters, and that would be 2 meters in actual distance on the Earth's surface. The question is, what number of actual meters are represented by 18 centimeters on the blueprint? So that means when I go 18 centimeters on the blueprint,
How much is
Okay.
it in my yard, my land
yes.
space, or that area where that person wants to do the building?
Okay, good. I can appreciate that. So how me do this now?
All right, so first we need to identify our scale.
Yes.
Scale is important. 10 centimeters to 2 meters.
Good.
Right? The information that we have is that we are working with 18 centimeters on the map, on the blueprint.
That's the distance on the map. Okay.
That we are working with.
Yes.
And we want to find out what is the actual measure, the real life measure,
Yes.
right? So, for every 2 centimeters,
For every 10,
for every 10 centimeters, it's 2 meters.
in real life. Good. Yes.
So we need to do that calculation.
Okay. So in order and to continue in that kind of comparison, we now need to know if we have 18 centimeters, how many meters would it be? So 18 centimeters to how many meters? Okay, I can use this information.
Yes, we can.
And we would have done basic operations already. I hope you can see a solution pathway. This is the one that I'm sharing with you. Yes?
So it's a unitary method. So
Yes.
we want to find out what 1 unit will value, and then we go ahead to find out what 18 centimeters would value. So we want to
Yes.
find 1 centimeter first, and then how much 18 centimeters will value. That's why we go ahead, we divide 2 by 10, and
So
then
divided by 10, multiplied
By
by
18.
And of course, when that computation is completed, we now see that if you have 18 centimeters on the map, it means that it has a value of 3.6 meters in
real
distance in real world.
Yes.
Okay.
some persons might want to apply ratio
Yeah,
to
yes.
do those kind of calculations.
Yes.
Because it is indeed a ratio that's
Yes,
there.
it
So they
is.
can feel free to do so if they want to.
And the truth is, whatever is most comfortable with you, whatever you're more comfortable using, whatever
Right.
information,
And that is
go
the beauty
ahead.
about mathematics. It lends itself to multiple solution
Thank
pathways.
you.
Right.
Yes.
So
Here's another
question.
one. Martha made a scale drawing of a swimming pool. The diving board, which is 10 meters high in real life, is 2 centimeters long in the drawing. What scale did Martha use for the drawing? Okay. So now I'm going to find how she scaled it.
Right.
All right. Good, good.
So if I randomly take 2 centimeters to represent 10 meters, then I will be correct. But if I want a simplified scale,
Yes.
then we need to do some amount of division
Yes,
there.
yes, yes.
So it would be 2 divided by 2, 2 being the highest
2
common.
divided by?
2.
Uh-huh.
2 being the highest common
Okay,
factor.
yes, I get you,
And
I
that
get
will
you.
give me 1 centimeter to want to find the amount of meters. So I'm going to use the common factor, the highest
To
common.
do the division, yes,
Right.
yes.
So I
Okay.
get 1 centimeter to represent.
So the scale that she used for the drawing is actually 1 centimeter to 5 meters.
5 meters.
Okay, we can work with this. Now here we have a practice question. Another practice question, which is a little bit more, it takes a little bit more for us to solve. Here we have a drawing, a plan of the ground floor of a building. And it has a scale of 1 to 250. Now this scale is a little different. On the plan, it says for each, the measure of each side of the unit or on the grid here, it is 1 centimeter. So now we understand that it is 1 centimeter to 250 centimeters. We are now required to complete this table. We are completing the table to find the length in meters. Please pay attention to this. In meters of the dining room, the living room, the kitchen, and the cloak room. We find the length, we find the width, and we will find the area. Now, before we go into completing the entire table, I want us to explore something just a bit. I want us to explore the dimensions of the dining room.
All right. So the length would be
1,
from here to here. So we can go ahead and count. 1, 2, 3. 4, 4, 5, 6, 7.
Okay.
And it is 7 centimeters. Right. So I'm going to make note.
So that's 7 centimeters. So for every 1 centimeter is 250 centimeters. So therefore, if I have 7 centimeters, it would be 7 centimeters multiplied by 250. Okay. To tell how many centimeters exist in real world. Okay, we can live with that. So that would be 1,750 centimeters.
Correct.
Okay.
But the table
that we have to complete says meter.
We want that information in meter.
Okay, yes.
So, what's our next question? How many centimeters will give us a meter?
Yes.
So, from measurement,
yes, I remember that it's 100 centimeters that will make 1 meter.
So we need to do some amount of conversion right there.
That's right, yes. Doing the conversion, of course, we know that you can do this at home. 1,750 centimeters is equivalent to 17.5 meters.
Right.
And if we use the same pattern to find the width, we see that it is 3 centimeters, that's represented on the plan. 3 centimeters on the plan. The actual distance would be 3 centimeters multiplied by 250 because we're using the scale. Because we're using the scale that is already identified. And we would get 750 centimeters. Convert that to meters. That would be 7.5 meters.
Good.
Good. So we have that worked out. We have that information.
So we are ready now.
We are ready.
Complete our table.
Thank you. So to complete the table, using the strategy that we just had, we identified the measure on the plan. We converted using the scale to get the actual distance, and then we converted centimeters to meters. And of course, this is the measure that we got for the dining room.
Denise, could we actually create a scale for the conversion right there, centimeters to meter?
That is right.
Right. So
that
it would have been for every 100 centimeter, it would give us 1 meter. So there are times when the first measurement is larger than what comes next.
And so, and the truth is we are to be able to use the information from what we learned earlier to help us to problem solve, to make our lives a little easier. Now, we would have gone ahead and done the calculations based on what we would have identified the measure on the plan, convert using the scale to get the actual measure, and then convert to centimeters.
But let's identify the dimensions while we are filling in the information. So for the living room, it would be...
Yes. Okay, good. And identified by the green, green that's the green there.
Area.
Yes.
The kitchen.
Yes, area, the
and we
yellow.
are working with all rectangles.
Yes, yes.
And it's
the cloak with red. So here we have the dimensions. Good. I hope you're there with us so far. Now to complete the table, we are now asked to find the area in square meters. How would we find the area in square meters? Of course, we would have gone ahead and done our multiplication. We would have been multiplying the length times the width. Now, you can do the calculations at home, and these are the measures that we would have got. I hope you can see that. Well, it is time for us to take a break, but stay with us. There is more after this.
Welcome back to class time, CSEC Math. Let's pick up where we left off.
Now, we left off with some practice questions, but I'm very eager to go into the CSEC, what would actually or could possibly be on the CSEC papers. And so this is our first CSEC practice question. We have a map here shown below on a grid of 1 centimeter squares, and it is P, Q, R, and S are representing 4 tracking stations. Now, our responsibility is to determine in centimeters the distance from Q to R on the map, highlighted there for us.
And it also states that it should be in centimeters.
Okay,
no,
so let's go ahead.
The scale is on the board, but based on what the question is asking, we really don't need to use the scale just now, because it's just a direct question. It says that we are to determine in centimeters the distance from Q to R. And it's highlighted with red.
Yes. So we just go ahead and count. Right? We count. Simple. So you get your mark. And that's it. You get your mark. So the scale is in centimeters, the scale is from 1 to 2,000. The distance on the map is 6 units or 6 square centimeters. 6 units or 6 centimeters. The actual distance, well, the actual distance on land would have been 12,000 centimeters.
But the distance on the map would be 6 centimeters.
Yes, that is correct.
Because we're using centimeter grid.
That is correct.
Square grid, so it's 6 centimeters.
For each side in the... Okay. So the next question asks us to determine,
and it tells
by
us how,
counting in square centimeters, the plane PQRS on the map.
Right.
PQRS, we have identified that shape right there for us.
And
so
we would have been given instruction that we need to count the square. So it says by counting.
Yes, it's
and
an
we know that the area is the distance that is enclosed inside PQR. So we could just go ahead and count
the number of squares.
Persons might ask what about the half or the less than half amount, but it's an estimate.
It is an estimate.
Could count and make our estimation.
Yes, and our estimated guess is that the area by counting is 18 square centimeters. That's the area.
That's the area.
That's not bad. We can say that's another mark. Good. I'm okay with that. Now, we are now asked to calculate the actual distance in kilometers between Q and R. Okay.
The actual distance. And is this a given? The actual distance, because we mentioned it earlier.
We mentioned it earlier, yes, so we solved it for you already.
So we need to bear in mind the scale, and it's 1 to 2,000, and because it is centimeter square grids that we're using, then it would be 1 centimeter to 2,000.
Yes.
And the information wants it in kilometers. So we are actually in centimeters now. So we need to do some amount of conversion.
Okay. And it's 6 centimeters between the points on the map or the stations on the map, Q and R. The actual distance would be, of course, we said it before, 12,000 centimeters. But we are being asked to give our answers in kilometers. And of course, talk to me.
100,000 centimeters will give us 1
kilometer.
And these are information that we would have had from, we were doing calculation, conversion.
True.
So this will stick with us.
Yes.
100,000 centimeters to give us 1 kilometer.
So how we use that information now?
Now, what we need to do is to convert our centimeters, that's a 12,000 centimeters there, to kilometers.
Okay.
And because we're changing from the smaller unit to the larger unit, then we are going to be...
We have a division
dividing.
Okay. And of course, ladies and gentlemen at home, please remember that the information that you would have learned earlier in previous years, they are very important for you when you come to problem solving now. Please remember that. And when we would have gone ahead and done our divisions, the division right here, we would have seen that the distance, the actual distance in kilometers between Q and R is 0.12 kilometers. Okay, so that's another set of points gone. Okay, good, good, good. Now, we are also asked to, between the 4 tracking stations, calculate the actual area. So first we did the area by counting. Now we're to calculate the actual area
in squared meters. So we are moving now from squared centimeters to squared meters.
Okay.
So we need to remember our conversion.
Yes.
Remember, what is on scale, what is on the map
Yes.
cannot be our actual distance
That is
in
true.
real life. We
That
have
is
to do
true.
some amount of conversion.
And we have to also bear in mind the scale that is given.
Right, that is
Okay.
why we keep seeing this conversion replaying itself in this context, right?
Yes, yes, yes.
Because of the scale.
Okay, so how do we go about solving this problem right now?
All right, earlier we found out that the area of the figure
By counting
by
our
counting the
estimate,
square,
yes,
was 18 squared centimeters. And we need to find the actual area.
Take me through.
Right.
Yes.
So in order to find the actual area, then we need to do some amount of conversion again. And if you notice there, it's 18. We're not just multiplying by 2,000, but we are multiplying by another 2,000.
So why are we multiplying by 2 sets of 2,000? We only have one down, one on the scale.
Right. So if we take randomly to say that we were multiplying, well, not for this case because this is really a trapezium.
Yes.
But if we were saying a length by a width, it would be a number multiplied by the conversion unit.
Okay.
So I am multiplied by another number by the conversion unit. So we would have
just counted. So we are using the information from the counting of the squares to do our conversion.
So doing the calculations, we ended up with a 18 right there.
Yes.
So we need to multiply to square because we square the
Squared, which would be, if we're
multiplying by
multiplied.
itself.
Yes. Okay. Okay.
So for this information that's there, it's for every
square centimeters.
Right. For every 10,000 square centimeters, it is 1 square meter.
Oh, 1 square meter. Okay, and they want us to find the actual area in the square meter. So again, we're doing our conversion, we're doing our division. We have 72 million divided by the 10,000, and we saw where the 10,000 came from because it's 10,000 square centimeters. That would give us 1 square meter. Whenever we do that calculation, we see that we have 7,200 square meters. This 7,200 square meters would represent the actual area in square meter of the plane that is identified on the map.
Given that the scale is
1 to
2,000.
Okay, that was much. I hope you got all of that, right? Okay, go ahead.
Another practice question. The scale on any map,
yes,
is 1 to 25,000. We are required to calculate the actual area in square kilometers represented by 2.25 square centimeters on the map.
From this, I deduce that the 1 is centimeter and the 25,000 would be centimeters as well. Okay, so I have that information. I also have the scale.
And you have the distance on the map.
That
you're trying
and I have to do the
actual area. Yeah.
So take us through.
The scale is given 1 centimeter to 25,000 centimeters.
Yes.
The area on the map is also given, and that's
2.25
square centimeters.
Yes.
Now, because we're squaring again, it is 2.25
multiplied by the 25,000, which comes
squared.
from the
Scale.
25,000 squared, which is 25,000 multiplied by 25,000.
And that gives us a very large number.
Oh, that is a large. That's 1,406,250,000 square centimeters.
Good.
That's a lot.
Good. Good. And
Yes.
then we know that it is 10 billion squared centimeters that will give us 1 square kilometer.
Yes.
So we do our division right there, and our answer for this case would be the actual area is equal to 0.140625 squared kilometers.
Precise, miss.
Yes.
You're
The question did not ask that we do any form of
Fair
rounding
enough.
off.
Yes,
So
yes.
we have our approximation, so we have to
Yes.
stick to the exact
Exact,
value.
okay. Precision. Okay, we can live with that. And then we have our next CSEC practice question. And I hope, ladies and gentlemen at home, that you're following and understanding what is happening. Yes? So here we have a diagram that shows a map of a golf course drawn on a grid of 1 centimeter squares. We are to use the map to find the distance to the nearest meter from the south gate to the east gate. We look on the map, we can identify the information that is there. We have north gate, east gate, south gate. We have the scale at the bottom, and we know that the grid is 1 centimeter squares. We are also, okay, continuing with the question, we are to find the distance to the nearest meter from north gate to south gate. Okay. The area of the ground represented by 1 square centimeter and on the map, and the actual area of the golf course, giving the answer in square meters. So let's look at these. The first thing is first. We would have identified the scale, and the scale is 1 centimeter to 4,000 centimeters. We understand the unit on the grid. Okay, so we are trying to find the distance from south gate to east gate.
Right.
We
So
would
we
have
could-
identified the locations on the map. Yes.
So we could go ahead and just count what's there. So we'll see that it is 1, 2, 3
Okay.
units on the map, and we need to give this distance to the nearest meter. But the question had given us in centimeters because we were working with centimeter
Meters.
square
Yes,
grid.
yes.
Right? So it would be 1 centimeter to 4,000 what?
Centimeters.
Centimeters.
Yes.
So if the distance from south gate to east gate
is
is
1 to 3 centimeters.
3 centimeters, then we
Yes.
need to convert this, find out the amount in centimeters, and then we convert to
Yes.
meters.
So that would be 3
3
multiplied by the 4,000. Yes, which would give us the what, 12,000.
12,000, and it's 12,000 in what? Centimeters.
Not forgetting our units.
Not
Okay.
forgetting our units, and we remember that
How
100
many
centimeters will
make
give us,
a meter.
and we're going to divide.
Yes.
So it would
The
be
12,000
12,000
centimeters divided by the 100, which would give us
120.
20. Okay, so it's simple. We have, oh, okay, yes. Okay, okay. Now, the next question asks us to find the distance in the, to the nearest meter from north gate to south gate. The distance on the map, again, we have to identify what's the distance on the map from north gate to south gate. But, oh, this is a
Right.
little bit different.
It is a little bit different.
Yes,
We
yes.
could have taken different pathway, but we already know that the shortest distance between 2 points is a straight line.
Yes.
That's why we connected a line there from...
From north gate to south gate.
No, one might ask, how are we going to be finding that distance? It's
yes,
a slant
yes.
line, and we don't know. We are not asked to use our rulers
No,
to
we
measure.
are not. We are not.
No, so we need to do some form of calculation.
Yes.
You would have been exposed to Pythagoras' theorem.
thought about that.
Right, so we
Completing
could
the
go
triangle.
ahead and complete not just a triangle, but a right angle triangle.
Okay.
Right, and using that, we can apply Pythagoras' theorem to solving this problem.
Okay, and that is that the square of the hypotenuse is equal to
the sum of the square on the other two sides.
Good, good. So we can do that calculation. And this is what it will amount
right.
to.
So we count our units to get 1, 2, 3, 4, 5. So we are squaring that 5 and 1, 2, 3. And we are squaring that as well. So it would be 25 plus
added
9.
To 9.
Yes, that would be equal to the hypotenuse square. We're using C in this case, but it is the hypotenuse square.
Yes.
Now, we do not want to find the hypotenuse square or the length of the line squared.
Yes.
That's why we would have gone ahead to find the square root
of.
And when we did that, our answer is 5.8 something.
Yes,
it's rounded off. And then we made an approximation to whole numbers to get it to be 6 centimeters.
Okay, so we see that the distance on the map from North Gate to South Gate is actually 6 centimeters. But are we finished in our calculations? Have we done what the question has asked us to do?
No. It wanted the actual distance.
Yes.
In meters.
Yes. So just as we would have done before, we know what the scale says for every 1 centimeter. We have 4,000 centimeters on the scale. We do that computation. So it is 6 multiplied, 6 representing the distance after we would have done our calculations. 6 centimeters multiplied by the 4,000 centimeters would give us
24,000 centimeters, and we need to convert this now to meters. Remember, 100 centimeters will give us 1 meter. So we go ahead again, divide,
division,
and then our answer would be 240 meters. And that is our actual distance.
Okay, so we would have answered the question asked.
Yes.
Okay, okay. We have another question a follow-up question from the one before. Now we are required to find the area on the ground represented by 1 square centimeter on the map. Okay.
Denise, this is what we call an irregular figure.
Yes.
So there is no given formula that we can use to find the area of this figure.
But we're not finding the area of all of it. We're finding the area of one of the square centimeters.
Yes. So we just need to identify one of the squares.
Yes. We have identified this one. That's right here. And so what they're actually asking is the area on the ground, on the earth, that this would represent, this shaded region would represent on the map.
And if we're talking about area on the ground, we know that it is our actual area that we're trying to find.
Yes, yes.
So on the map, it is 1 squared centimeter.
Yes.
What is it on the ground? What is it in real life?
To get 1 squared centimeter, I would say that we use the dimensions 1 centimeter by 1 centimeter to give us the 1 centimeter squared. Okay, so in order to do that, we have the 4,000 multiplied by 4,000 on the ground. And of course, we get this beautiful 16 million square centimeters on the ground. Okay, then. Okay. It's time for another break. Class time continues after this. Stay tuned.
Welcome back to class time. Let's continue the lesson.
Okay, so we left off doing
The area
yes.
of 1 squared grid.
Thank you.
Yes.
Now we're asked to find the actual area of the golf course, giving the answer in square meters.
So are you seeing where we're going to be using the solution that we would have gotten in the previous question? We could have.
We could have. So take me through that.
All right. So it did not tell us how to go about and find the area of the golf course. Looking at it, as mentioned earlier, it is an irregular figure. So we cannot definitely identify, say it's a rectangular, triangle, whatever it is.
Yes.
Because there are also curved edges.
Yes.
So it's an irregular figure. The best way now to find the area of this would be by counting the squares.
Which is an estimate. So we use an approximate value for the area. Okay.
When we counted the squares, we got 30 small squared centimeters right there.
Yes.
So the
we need to know the actual measure on the ground.
Right.
Good.
So to summarize, the area of this golf course is estimated to be 30 squared centimeters. Right. Now,
as is represented on the map.
As is represented on the map. Using the scale 1
to 4,000.
To 4,000. Now we need to find the actual area
on land in square meters. Okay.
So, go ahead, Denise.
So we use the area that we would have got by counting. Of course, we would have multiplied the area by the scale that is there, that is 4,000 square centimeters. That would give us 30 multiplied by 4,000 multiplied by 4,000 to give us this grand total of 480 million square centimeters.
Yes.
And of course, we need to use the information that it's 10,000 square centimeters is equivalent or is equal to 1 square meter. How do we use this information? Of course, we go ahead again and we do our division. It is 480 million divided by 10,000, and the final answer would be 48,000 square meters. We would have got our answer, right?
Yes.
Okay. Ladies and gentlemen at home, I hope that you would have been following and things are a little clearer for you. To take us to another CSEC practice question, because the last one was it was a lengthy one. So that would be a value of something like 12 marks or so. Here is another one that would...
This aspect of mathematics is also tested on the multiple
choice paper 1.
Yes.
Awesome.
So, what is the length in kilometers from town A to town B on the grid below?
Okay.
So they gave us
town
a scale.
A, town B, scale 1 to 100,000, and each small square has 1 centimeter sides.
Yes.
Good information to have. Now, we are asked to find, it's multiple choice. They ask us, is it the answer A, 5 kilometers, B, 50 kilometers, C, 500 kilometers, or is it D, 500,000 kilometers? We would have gone ahead and identified, we have done this before in one of the items questions before. Yeah. We have identified 4 centimeters for one side. We've created our right angle triangle. We're going to use Pythagoras' theorem to help us. So we have 4 squared added to 3 squared.
Just a minute right there.
Talk to me,
Denise. Looking at that, I know that it is jumping out at some of the viewers to say, yes, because 3, 4, 5 triangles. So that length must be 5. And they're going to give us 5.
This is a given.
They're going to give us 5 kilometers, right? But did is the length that's there in kilometers or is it in centimeters?
It is in centimeters.
So we must understand our question before we jump to choosing an answer.
Correct, correct.
So 5 kilometers would not
Most
be
definitely.
Yes, you are familiar with the 3, 4, 5 triangle,
yes.
right angle triangle.
Yes.
But in this case, 5 kilometers
would not
doesn't work.
Yes, yes.
So let's go ahead.
Okay, so again, they would have, I'm doing this just for those persons who, you want a little clarity.
Confirmation.
Confirmation.
Right
exactly, you get it right already. So we would have identified that the distance on the map from point A, town A to town B is represented by 5 centimeters. How do we use this information?
No, 5 centimeters, we need to convert this to kilometers.
Okay.
So we need to know how many.
1 to 100,000.
Right.
Okay. So 1 to 100,000.
When we multiply
Yes.
5 by 100,000, then our answer would give us 500,000 kilometers.
And that would have been our answer. Good. That's 1 point and we're okay. Good. Now the next question. Still a multiple choice in paper 1, and we have a selection. We have 4 answers from which to make a selection. It says in each square, if each square represents 1 square kilometer, the approximate area of the island in square kilometers would be A, first, 23 square kilometers, 230 square kilometers, 50 square kilometers, or 25 million square kilometers.
Right.
Help
so
me.
it is important to understand that in this case, 1 square kilometer, that's one of those little square, will have dimensions 1 kilometer, 1 kilometer. So when we count all of those, our answer would be
I look at it.
23 square kilometers.
So for today, we have done much. For today, we read the different representation of the scales on the map, and we used maps and scale drawings to determine distances and areas. That was much, right?
Well accomplished.
Well, I believe so. I believe so. And that is it. We've come to the end of our measurement series. You can watch a repeat of this lesson on JNN at 5 p.m. And for other lessons in the series, you can access One Spot Media on demand.
Class time continues tomorrow with English language. If you are away from your TV, you can watch the lesson in real time on Television Jamaica's YouTube channel or One Spot Media.
Until next time, stay safe.
Hi there, I'm Simon Preston from TVJ. Thank you very much for watching our YouTube channel. To see our latest videos and also to see live events, click here. To see our full videos on onespotmedia.com, click here. Thank you very much for watching.